Question 10. The time, t seconds, that a pendulum takes to complete one swing is modelled by the formula t is equal to a times L to the power b, where L meters is the length of the pendulum and A and B are constants. Part A, show that this relationship can be written in the form log base 10t is equal to b log base 10L plus log base 10A. So starting with our t is equal to AL to the power b, if we take logs of both sides, in this case log base 10, the right hand side here, we can use our log rules to rewrite this. The first log rule we're going to use is that if we have these two things here, so I've got a and L to the power b multiplied by each other, that's the same as log base 10a plus log base 10L to the power b. So it could be rewritten as this. Now this log base 10L to the power b, this is going to use our next log rule, where if we have log of something raised to a power, we can bring that power in front. And so this log base 10L to the power b is the same as b log base 10L. And now we're almost in the form we want. We just need to swap around these two terms here. So we've got log base 10t is equal to b log base 10L plus log base 10a, which is what we wanted to show. A student carried out an experiment to find the values of the constants a and b. The student recorded the value for t for different values of L. Figure 3 shows the linear relationship between log base 10L and log base 10t for the student's data. The straight line passes through the points minus 0.70 and 0.21, 0.45. Using this information, for part B, find a complete equation for the model in the form t equals a L to the power b, giving the value of a and the value of b to three significant figures. Okay, so first thing to note here is that we've just written this equation in a linear form. So notice the x-axis is labelled log base 10L, so this log base 10L is almost our x value, and this log base 10t is our y value. So I'm going to keep this part of the question here for part B, and I'm looking at the equation y equals mx plus c. And so, as I've said, x value is our log base 10L, and our y value is log base 10t, which means from this, to find b, it would help if I can find m on this line, and also to find a, it would help if I can find c. And so given this, I need to find y equals mx plus c for this line. Well, starting with the gradient of this line is going to be y1 minus y2, so 0.45 minus 0, divided by 0.21 minus 0.7, which gives me a gradient of 45 over 91. Now, as we've said, b is equal to m in this form, and so b is equal to 45 over 91. So given this coordinate minus 0.70 and the gradient of this line, I can write the full line equation of y is equal to 45 over 91, lots of x plus 0.7. This allows me to find the c value. C is going to be equal to 45 over 91 multiplied by 0.7, which is 9/26. Now c, as we've seen, is equal to log base 10a, which means a is equal to 10 to the power c, so 10 to the power 9/26, which is 2.218 and so on, which to three significant figures is 2.22. So now I have a and b, I can write my complete equation. T is equal to 2.22 L to the power 45 over 91. With reference to the model, interpret the value of the constant a. If t was equal to a and L to the power b was equal to 1, that would be a length of 1 meter of the pendulum. And so a is going to be the time for one swing of a pendulum of length 1 meter. So, interpreting the value of A, it is the time of a swing for a pendulum of length 1 meter.